What new CFS biomarker discoveries could reduce test prices? Recent research has brought exciting news for those affected by myalgic encephalomyelitis chronic fatigue syndrome. Scientists are uncovering promising biomarkers that could lead to cheaper and more accessible tests for diagnosing this complex condition. These discoveries focus on blood-based markers, immune system signatures, and even microbiome profiles, all of which can be gathered through simple methods like blood draws or stool samples. One major breakthrough involves circulating cell-free RNA signatures. A study found that this RNA in blood plasma can act as a sensitive biomarker for CFS. Researchers used machine learning to create a diagnostic model based on these RNA patterns, achieving high accuracy in distinguishing CFS patients. This method highlights immune dysfunction and chronic inflammation, and because it only requires a blood sample, it could be a scalable and cost-effective testing option compared to more complex evaluations. Another exciting development comes from analyzing the gut microbiome. Researchers discovered distinct microbial and metabolic disruptions in CFS patients. By employing artificial intelligence to analyze stool and blood samples, they achieved around 90% accuracy in identifying CFS. These microbiome-based biomarkers could lead to non-invasive diagnostic panels that relying on standardized sequencing and computational analysis. As these technologies become more common, they may help lower costs over time. Additionally, large-scale analyses of blood samples have revealed consistent differences in markers related to inflammation and metabolic dysfunction in CFS patients. This suggests that panels measuring specific proteins or immune cell profiles could serve as reliable biomarkers. Since these tests can be performed using existing laboratory infrastructure, they hold promise for cost-effective diagnostics. Researchers have also identified distinct immunotypes based on cytokine profiles in cerebrospinal fluid. While collecting cerebrospinal fluid is more invasive, ongoing studies aim to translate these findings into blood-based immune biomarker panels. Understanding these subtypes could lead to more targeted testing approaches, reducing unnecessary broad testing and cutting costs. The practical implications of these discoveries are significant. The use of machine learning and artificial intelligence allows for the development of diagnostic algorithms that can be run on standardized platforms, reducing labor and interpretation costs. Biomarkers that can be detected in blood or stool samples avoid the need for expensive or invasive procedures, making sample collection simpler and cheaper. As these biomarkers are validated and integrated into clinical practice, they could replace the current reliance on costly clinical exclusion diagnoses, ultimately lowering diagnostic expenses. Furthermore, identifying biological subtypes within CFS could enable more personalized testing strategies, moving away from one-size-fits-all expensive panels. Overall, these new biomarker discoveries representing a shift toward objective, biology-based diagnostics for CFS. While these tests are not yet widely available or fully validated, their development could significantly reduce costs and improve accessibility for patients living with this challenging illness.